Welcome to Direct Technologies. If you want to follow us on YouTube, we are Direct Technologies. So today I want to show you simple way on how to create a Vee block. So this is a Vee block. This is the isometric. Isometric meaning it has the front plane from this elevation is able to be seen. It has the right plane from this elevation, and it has top plane from this elevation. So if you using your eye, from this elevation is the top, from this elevation is the right, from this elevation is the front. Then the purpose of the Vee block normally is to hold circular features or shafts. Maybe you're holding a circular shaft on a machine so that it doesn't affect the concentricity when you're doing operation like cutting, drilling holes or drilling, and also when you are cutting slots using your maybe milling machine. So we want to create this symbol. Our measurements are in millimeters. So basically, we are going to create the first one. So there are types of Vee blocks and their specs. So these are some of the categories you can use. Actually, it is good. I've put a table. So the width is this, then the height, and then the length. It goes along the way, and then the thickness. The thickness. What do we mean by the thickness? I'll explain as you proceed in the next session. So let me open this. Open this one. There's inventor. Then we do a symbol design in inventor. So we are going to create a profile. This profile front plane. So we can create this one. Yes. So let's go to our inventor. We can go to our inventor. Yes, where is our inventor? It is here. So new file, standard inventor. So we're using front plane. And I'll show you how to rename the planes in inventor. Show you how to rename planes in inventor so that it can be easy for you to use them. So this is the inventor. This is the right plane. Right click on it, then you can press F2. Left click, then press F2 and say right plane. This is the top plane. Left click, then press F2, then you can say top plane. This is the front plane. Left click, then press F2, say front plane. So because our part is, if you look at the, basically for you to do simple design, look at the isometric. This isometric, you can use either right plane or front plane, but mine I want to use the front plane. I do this sketch, which the height is 9, the height is 8. We're using the first model. We're going to use the first model. The height is 90, the width is 100. So which means is almost category this one, the VBLKDH2. So we are going to use that one to do our symbol design. So let's go to our inventor. So front plane, create a sketch. You can take a center line, create a line here like this. Make this one line horizontal. Take only this concentric. This one, dimension this one. We're taking it as 100. Enter. Press F. Then a line here. It goes all the way vertical. Then I want to do a single mirror from here. So we can get this line, saying this is for construction, and then we can take coincident from here to here. Yes. Then you can say the height is 8. This is 8. press F, front plane. Then whatever I'm going to sketch here, I'll do a symbol mirror so that it can be seen on the other side. So do a mirror, this line, this one, even this mirror line, this one, apply, done. Smart dimension, we are saying that this is 10. That's the T now that I was explaining. You can say symmetry is okay because this one should be 90 degree. Then there's something else here I need to put. This. I've put this one. Why? Because I want to show you how to put the symmetry. So this one and this one, you say the symmetry, and then it is going all the way to 40 from here up to here. It's going all the way to 40. Yes, and then the gap is, this gap is 10. Gap is 10. So I can trim now this and this one. Then I can say this line is, this one and this one are linear, automatically are linear. If you find them not having the dimensions, then you can go and make this one 5. This is 5. Yes, they automatically come. The height automatically come as 5. Then we can also put the holes. Automatically you can put the holes. Hole here. I want to mirror this one. Then mirror line is this. Apply, done. And then from both sides, from here to here, it is 45. And then 20 from this to here. This is 20. The diameter of these holes. What is the diameter of the holes from the design? So now these holes will depend on your clamping. How are you going to clamp it? It may be different how you are going to clamp it. Maybe mine, I'm going to clamp it using M12. M12 minus, if I'm putting a thread, I want to clamp somewhere, I can put M12 minus 2, that is 10 if I'm using a isometric. Then I can finish this. So this is a sketch. From here I can create a 3D model. I want to make it symmetric. I like putting symmetric. Then here I can put the length is 100. L is 100. Okay. Okay, so we have put our symbol, and then you can do a chamfer. Let me put a chamfer of 1 for easier of putting our thread. You can also put a chamfer this side. Chamfer. Then my Vee Block, I'm assuming I'm going to machine using which material? Let me put, I like using, for this one, you can use the cast iron, but the cast iron can break easily. So let me look for steel, alloy steel. I think I like alloy steel, where is it? We can use the steel, we can just use the normal steel, this steel. Okay, then we can put thread. So this inside, let me say isometric, my hole automatically has put the diameter of 10, so let it be, because I know I'll be using M12, so I'm using M12 by 1.75. So if it is M12 by 1.5, so automatically the hole, I can change the hole first, the hole here from this, if I edit the hole should be, it is 12 minus 1.5, so that is the diameter. Then I'll put the thread on this inside, so I'll put a thread for this, which will be still okay. I'm going to put it through 100. 100 can be too big, so I can put 50. Yes, 50 is okay. I can add this. I saw 50. Okay, so I've put my thread. I think this material may not be so it may look awkward visibility wise, but I know I'll be using steel. So this is the Vee Block we have done a symbol design. When you look at the original one here, so we have done this part where our width here, which our width here was 100. So if let's say this was 100, I can write, let me use my pen. So this is, I've used the 100, yes, the 101 here. Then here I've used 80. I've used 80. Then I've used the length as 100. So I've customized mine, but you can use this table. You can use this table to create your own Vee block. So the holes may depend, because I've said it is diameter 12, but I'm using the steel, that is my material is mild steel. Then it is two holes which has diameter of 12 through hole. But I'm using M10, that is M12 by 1.5. So if you're using M12 by 1.5, isometric thread would be that is 12 minus say 1.5, which is almost 10 point. That is a 10 point. 9 point, is it 9.4, 10.5? Should be 10.5. So that is what I've put as my thread. So when you look at now the design, this is what it gives me. Let me look on the front plane. Now this is the front plane, how it appears. If I'm going to look at the top plane, this is the top plane, that is the top elevation. And then if you're looking at right elevation, this is what I'll be seeing. Maybe let me put the view, let me put a wireframe so you can see how it look like on the right plane. On the front elevation, this is what it will be looking like. And then on the top, this is what it will be looking like. I can change even the view. Maybe let's say a wireframe with hidden edges. So because when you look at the top elevation, you will not see the holes, but you will see these dotted lines, which means they are hidden. If you look at the front elevation, you can see all of them except the holes on the right plane or right elevation. So this on the right elevation, this is what you'll be seeing, because I've put a chamfer of one at the end of it. So this is the Vee block. We have done a simple Vee block design from the material and from the drawing that was given. Thank you. Have a lovely day.